Okay, so we are going to look at another problem that deals with the addition formulas for trigonometry. This time is going to be the tangent formula. Okay, so the problem is find the tangent of these two guys. Well, obviously inside the parentheses here, we're adding these two guys up. So we're going to have to use the formula for this, obviously, and we'll get to that in just 1 minute. But what I wanted to do first was find out, well, what is this? What's the tangent of this? What's the tangent of that? Because we're going to need that in our formula. So what I first observe is that 11 pi over 6, 11/6 of a pi is almost 2 pi, right? 11 over 6 is just a little bit less than 12 over 6. 12 over 6 is 2. So 11 over 6 times pi is a little tiny bit less than 2 pi. It's 1/6 pi less than 2 pi. So if I were to draw a picture here, if I went around like this, if I went all the way around and I went all the way up to here, that would be 2 pi. But I'm not going to 2 pi. I'm only going to 11/6 of a pi. So how much of a deficit do I have? How much more do I need to go to get all the way up there? I need to go up there 1/6 of a pi. So you know how this works. When you have something like this, a non-acute angle, the trigonometric function, whether it's sine, cosine, tangent, or whatever, so in this case tangent, the tangent of this bigger angle, the non-acute angle, is just the tangent of the acute angle here. And we have to worry about, is it a plus or a minus, okay? So that's why we use this rule. All students take calculus. So we know that in this quadrant, the tangent of the big guy is going to be the tangent of the little guy, but it's going to be the opposite sign. So it's going to be negative. Okay, so it's in quadrant 4, so tangent of 11 pi over 6 is -1 times tangent of pi over 6. Well, I know what tangent of pi over 6 is. I got a table for that. Tangent of pi over 6 is √3 over 3. Okay, so from the table, tangent of 11 pi over 6 is negative root pi over 3. Also from the table, tangent of pi over 4 is just equal to 1. So now I have everything I need to solve this problem, obviously, except for the formula. So let me write down the formula. And I am going to kill people if they don't write down these formulas. You've got to write down the formulas every single time. So here's the formula, okay? Then I plug in what I'm looking for, and then I plug in over here on the right-hand side the appropriate guys. So my alpha is 11 pi over 6. My beta is pi over 4. I just plug things in. I plug in the numbers that I got up here. So I plug in those numbers. I'll let you look at that. I'll write it down. And then I get this, okay? 1 take away √3 over 3, 1 plus √3 over 3. And then now it's just a matter of manipulating it. If I leave it like this, that is the exact answer. But most instructors, most books want you to reduce things. They don't like radical signs in the denominator. That's just a convention, okay? So what we have to do is we have to play around with this just a tiny bit. So the first thing I'm going to do is I'm going to say, well, I sure don't want fractions in the top and fractions in the bottom. So let me get rid of all these fractions in the top here. 1 is just 3 over 3. 1 is 3 over 3. So if I make this 1 into a 3 over 3, and then I can kind of play with it on top here, I got a denominator of 3, denominator of 3, so those denominators just basically go away, right? So on top I have 3 take away √3. On the bottom I have 3 plus √3. Okay, so now you could, if you left it like this, that looks more simple than this, doesn't it? However, we still have this radical sign, and as I say, the instructors don't like that. So what we have to do is a trick. Here is the trick. When you have something like this on the bottom, 3 plus √3. You multiply by the conjugate. You multiply by the conjugate of this guy. The conjugate is, you just change this middle sign here. 3 plus √3. The conjugate is 3 subtract √3. Okay? And if you multiply that out, and this is kind of the subject of a different video, but if you multiply, let's just change it to let's just change it to variables. A plus B times A minus B. Multiply that out on your own. A plus B times A minus B. What you come up with is A squared minus B squared. That's just an identity, okay? That's the identity called the difference of squares. So if you multiply 3 plus root 3 times 3 minus root 3, what do you get? You get 3 squared, there it is, 9, and you get root 3 squared, there it is, it's 3. 9 subtract 3. So on the bottom you get 6. Now on the top you have 3 subtract root 3 times 3 subtract root 3. Well, that's the same as 3 subtract root 3 quantity squared. Hopefully you know how to do that. That's that's the first guy, 3 squared. Take away 2 times 3 times this guy, so 2 times 3 times root 3 plus root 3 squared, which is 3. This is all Math 35 stuff that you may be rusty on. But, all right, so you get that. And then on the top then, we're going to combine the terms. 3 squared is 9 plus 3, there it is. 2 times 3 times root 3 is 6. On the bottom, we just got 6. He just sits there. So on the top then, we get 9 plus 3 is 12. Take away 6 times root 3. I can factor out a 6. When I factor out that 6, I get 6 times 2, take away root 3. And on the bottom, I get a 6. Boom, these guys cancel. So what do I have? 2 subtract root 3, and that is the correct answer according to my answer key. Thank you. I gotta turn this thing off.